Next we're going to be testing the tubes. Let me just adjust this a little here to get a better picture. And maybe we'll zoom out a little to get more involved. Good. Alright, the first tube is a 12SK7, which is a standard tube on All-American 5. This one is a really good shape. If you look at it, it looks almost brand new. It's not original with the radio because it's a Silvertone radio and this is a General Electric. I'm going to put it in here. And the 12SK7 is part of the IF amplification circuit. So it's, all tubes are important, but that's very important. Down here we have this little dial that you can look at the tubes and figure out the settings, but because I do have a booklet that's updated, which isn't being shown in a picture, I'm going to go from there. I'll just kind of share this with you so you can see. This gives us kind of the same information as the scroll inside the machine, but it's an updated version. So 12SK7, we have to do the circuitry, has to be on 4, which it is. The filament, because it's 12 SK7, we're going to put 12.6. The number on a tube corresponds with the voltage amount. Okay, the load, we're going to be putting, having trouble seeing, pardon, 12SK7 52, so we move this up to 52 here. And here we have to put up number pin 6 and 8. That goes up and down pin 2. So you always want to let the tube warm up for a little bit before you try it to get an accurate reading. And you can see it building up and moving and moving. I'm sure if I let this sit for a while it would move all the way up to 100%, but you can see we're already in the 90s, so this tube is surely good. Now what we want to check for is shorts in the radio, and we can do that. Each tube has a little special character in the documentation. In this case it's number 7, so if I'm sorry, in this case it's not number 7, it's number 6. So what I do here is I take the number 6 tube pin here, that's up, I hold it down, sorry, pardon me, I had that backwards. I was right the first time. It is number 7. So if number 7, I push it up, and that shows there's a short right there. And that's what it's expecting if you put number 7. So that's fine. Now what I was saying earlier is number 6. I'm going to check it for gaseous emissions. I hold the short value here down, I hit number 6, and the gas test should go to good, which it did on there. So this tube looks like it would be fine, and I will test the next tube. The next tube is a 12SA7. This is part of the converter circuitry. And we actually have a couple of tests we have to do with this one. The circuit should be number 4, which is accurate. It stays on, the filament stays on 12.6 as it should. The first test, it goes to 44 for the load. I should be pushing these back here. 3 and 4 up, 2 is down. And now we'll just hit the value to see what it's going to look like. Over 90%, so this tube is good for that one. We will also test the gas test. It's fine there. And we'll also test a short test, which in this case is number 4. Sorry, I did that backwards. I keep doing that backwards. The gas test is fine on this one. And number 7, we should get the short test, which we do. The second test, let's reset these. We move up to number 45 for the load to circuit, and the filament stay where they are. In this case, 4 is up, 2 is down, and this second test is good as well. And the short test is fine. In this particular test, there is no gas test at all. So this tube should work out fine. By the way, on the schematic and the actual parts list, all these are called for GT at the end, which stands for glass tube. But obviously glass tubes, as they were replaced with other things, metal tubes serve the same purpose. And I think they're actually probably better in the sense that they offer some protection because they're encased in metal. So you get some interference protection. All right, now we're looking at a 12SQ7. I've been kind of wiping it off. In this case, I don't have an 12SQ7 in my booklet. The 12SQ7 is the detector, audio frequency, and the automatic volume controlled. And that's the features it uses. Circuitry it takes care of. So let me look. 12SQ7. Let's move down here. Okay, this one happens to have 3 tests. Circuit's number 1. 12.6 is fine for the filament. We move up to 50 for the load. Okay, and the first one is, I'm sorry, there's a couple of tests in the same line. This actually is 22 for the first one. 26 is up. 4 is down. Sorry, 26 is up, 37 is down. In this case, you probably can't see it, but some of the numbers are in bold, and that's the one that you should be able to do the short test with. So if I move the 7 up, you'll see it'll short. So we'll try the test. And he's 70% climbing a little more. So this tube should be good. The second test, put these back. The second test is 50 on the filament. And 4 is up in this case, and 37 is down. You can see it has another chance to warm up a little more. It's slowly climbing, although it's not climbing quick enough. This tube may be bad and may have to be replaced. It's in the yellow, which means it'll probably work, but I don't want it just to work. I want to be able to get a good tube going. So let me just make sure my settings are right. I have 1 for the circuit, 12.6 for the filament, 50 for the load, 4 is up, 3 and 7 are down. Yeah, this tube is very weak, so I will have to replace this one. I won't bother with the third test since this one's failing. The next what I want to try is the 37Z5 GT, which is a glass tube. Now it's kind of hard to see on the camera, but the writing's right there. You can see it's a little dirty, so I'll clean it off. One thing to be careful of is that the writing on here, the 37Z5, can easily come off with water. So if you're going to clean it with water, avoid cleaning right where the lettering is. I'm just going to do this off camera for a second. Okay, so he's cleaned up. Put him in. I'll go back now to my book. 37Z5, I know that's in here. I'm sorry, 35Z5. 35Z5, there it is. And the 35Z5 is the rectifier. This basically converts the input from AC into AC and DC, so the radio can work. 35Z5, the circuitry goes in number 4. It's 32 volts, so the closest thing is 32 here. That's what we go to. 26 on the load. And what's next? 35Z5. 5 is up. And 3 is down. You get actually different with the glass tubes. You actually see the lighting glow here. That tube looks perfectly fine. Very good strength. Okay. 35Z5. What are we going to 2 and 3? So we're going to do the gas test here. It's fine for pin 2. Fine for pin 3. So this tests out fine. One more to go is the 50L6 GT. Trying to see that. And this is the power output tube. I'm just cleaning it up off camera. Okay. Put the power back on. And I think I said 35. This is 50L6 GT, which is the power output tube. So I'll take my item here, 50L6. Circuitry is number 4. The filament goes up to 50 volts. We put the load to 28. Pins 3 and 4 are up. Pin 2 is down. Ooh, did you see that flash? That's not a good thing. I'm going to bet this just blew out the tube. Let me make sure I have the right thing. Yeah, 50. Make sure that's a 50. Yeah, this thing's dying. So this tube really wasn't going to be very good to begin with. And my guess would be there are shorts in it as well. So I'm just looking here. Okay, I had to drop off for a second because somebody was coming down into my workspace making noise. I didn't want it to be on the video. I let this sit for a while, and it's actually showing that this is good. So I'm not quite sure what that flash was, but I think we'll determine in the radio once it runs if this is actually a tube is still fine or not. The other thing I still need to check on this, on the 50L6, is the gas test. It's fine, and I want to do the short test also, which is pin 7. So it looks good. Alright, so right now we only have the one tube that needs to be replaced, and I think I may have some extras of that one. If not new, I have some from other radios that still need to be repaired. That is all for this video. I hope you enjoyed it. Thank you, and looking forward to the next one. Have a good evening.